Okay, we're going to start talking about triangles, and one important thing about triangles are sides. So obviously sides are, these lines, these line segments rather, but how are they actually defined? Well, sides are the line segments connecting the vertices. Now, that's important because you're going to have three vertices and three sides. Those sides go from one vertex to the other, and that's what gives you a triangle. Now, there are interior angles. Interior angles are just going to be the angles inside of the triangle. So there are three angles that are inside of a triangle. These add up to 180 degrees. So you can't have more than 180 degrees inside of a triangle. Exterior angles are the angles outside, but you have to be careful because exterior angles actually are just extensions of these lines. So notice here that I draw these straight lines. So these exterior angles right there, those are all just the supplements of the interior angles, which is kind of cool to think about. But these, oops, these add up to not 180, but 360 degrees. If I look at all these angles and add them all together, I'm going to get 360 degrees. That's not too important of a rule, but definitely interior angles is. All right, then we're going to classify our triangles. Acute angles means that all three angles are acute. So we know that an acute triangle is, or an acute angle is an angle that's less than 90 degrees. So an acute triangle would look something like this. So all three of these angles, we don't know really what they are, but they are all less than 90 degrees. We can also have a right triangle. A right triangle is going to look just like this, and that's actually a special type, but we could drag it out there. So a right triangle has a right angle. Now, if you think about it, the interior angles add up to 180. So that means that these two angles must add up to 90, which means that they are both acute. Now, it's not that they're both 45 because they don't have to be equal. But they both are acute angles because if one of them was obtuse, this triangle would be larger than 180 degrees. It wouldn't work. It wouldn't be a triangle. And then we have an obtuse, which, there we go. Oh, that was not good. Let's try that again. So an obtuse angle is an angle that's greater than 180 degrees. So do the best we can, right? So this has an obtuse angle. So acute angle, all three angles are acute. A right angle has two acute angles, one of which is right. An obtuse angle actually has two acute angles, one of which is obtuse. We could also classify triangles based off of their sides. Equilateral, you can see that word equal, means that all three sides are going to be the same. So we could have, we could have a triangle like this, where all these three sides are the same. So all three sides the same, or, congruent. It's probably a better way to say that. All three sides are congruent. Also, if all three sides are congruent, actually, all three angles are also congruent as well. So a cool little tidbit there. That's very, very important. So if we see that all three sides are congruent, we can then assume that all three angles are also congruent. An isosceles triangle is where we have two sides that are congruent. So this side and this side are congruent. Now what's really cool about this is that the opposite angles are congruent. So the angles opposite of these sides, so right there, so there's that side, there's the angle, there's the side, there's the angle. That means that these two angles are also congruent, which is cool. So a right triangle that is also isosceles is a 45, 45, 90. That's just one example. You can see that these two angles are the same, as are the sides. Okay, and then finally scaling. Scaling is kind of the oddball. So all three sides have a different measure. So something like this. So there's 1, 2, and 3. So if all three sides have different measure, then yes, all three angles, all with 3 L's, all three angles are also different measure. All right, and that's scaling. So equilateral, isosceles, scaling. Hopefully you've heard of these words before. You can do a better job committing them to memory if you haven't already. So based off these pictures, we want to figure out which triangle is which. So where do we see a right triangle? Well, if we look, there's a right angle. So that's going to be EAB. So triangle EAB. Notice how I write this triangle first to say, hey, EAB is not an angle or anything, it's a triangle. Also, I could write AEB or BAE or whichever order as long as it goes in order. So I did EAB, that makes that triangle. But just make sure I don't say like, well, later on it's going to be important because when we talk about angles, triangles which are congruent to each other, the order does matter. But we'll cover that later. All right, an isosceles triangle. I guess there's actually one more right triangle. We also have this CBE, triangle CBE. For an isosceles triangle, two sides are congruent. So here EBD, so that's triangle EBD. And I think that's about it there. Scaling means all three sides are different. So if we actually look at CBE again, so triangle CBE, notice side EC is 2 of those little marks, BC is 1 of them, then EB is unlabeled. So that's how we get that. And then obtuse is, we have to look for an obtuse angle. Actually there we can see it. So that would be 1. So triangle EDB. So you can see that sometimes we can have triangles which are both isosceles and obtuse, and also right and scalene, because the classifications for sides, such as scalene and isosceles, can also overlap classifications for angles, such as right and obtuse. All right, we want to do the same for these types of problems. So we want to identify the indicated type of triangles if all these sides are congruent and, you know, these two line segments are perpendicular. So right. Is that actually the same? No, it's very similar though. So where do we have right triangles? Well, we're going to have a triangle ABC and also triangle EDC. An obtuse triangle. Looking around here. Well, it looks like this triangle's obtuse, but can't we really say why? Well, definitely triangle BDE. We'll come back to that. Scaling is going to be, yet again, that big triangle, ABC, because we can see that this side is 2 tick marks, this is 1, and that's a different. And then we have isosceles, which means 2 sides are the same, so we have triangle BDE. Going off that this is obtuse triangle, it's really difficult to kind of prove that, but that is going to be an obtuse triangle. For the quiz, for the test, I will be as specific as possible, and I will give you as much information as you need to get the answers. All right, we can also have different algebraic equations. So triangle ABC for number 11 is equilateral. So if I just draw a picture, right, ABC, all 3 sides are congruent. AB is 3x minus 2, BC is 2x plus 4, and CA, or AC, is x plus 10. We want to find x and the measure of each side. So we could take any 2 sides, it doesn't matter. Here I could say 2x plus 4 is equal to x plus 10, and I'm going to get x is equal to 6. So knowing that x is equal to 6, I can plug that in and find that AB is equal to 18 minus 2, which is 16. BC is equal to 12 plus 4, which is 16. And CA is equal to 6 plus 10, which is 16. And I know what you're thinking. I already knew this was equilateral. Why did I go and plug it into all of these? Simply to check my answer to make sure that I did everything correct. Because if I got any other sides, then that would tell me that my x was incorrect. Our triangle DEF is isosceles. Angle D is the vertex angle. So that means that that is looking like this. So DE and EF are congruent. So DE is x plus 7, and DF is 3x minus 1, and EF is 2x plus 5. Yet again, to find x, we can set the 2 congruent sides together. So we get 3x minus 1 is equal to x plus 7. So that gives me 2x is equal to 8, or x is equal to 4. Knowing that x is equal to 4, I'm just going to drag this down just a little bit. Knowing that x is equal to 4 for number 12, I can get that DE is equal to 11. DF is equal to 12 minus 1, which is 11. And then EF is equal to 8 plus 3, which is 13. So there we can see we have that isosceles nature. 2 sides are congruent. So make sure you understand how to set up these equations. Draw a picture if you can't do anything. But when you're doing these problems, make sure you're writing something down. First the picture, then the equation, and then check your work. It's just that simple. If you don't do this, then you can't get the answer correct. And you can't be upset with yourself that you can't get the answer. So make sure that you're doing all this work. All right, now we want to look at these points and decide what type of triangle we have. Well, if we graph it, we have R, which is at 0, 2. There's R. Then we have S, which is at 2, 5. 3, 4, 5. And then T, which is at 4, 2. Wow, lovely drawing, right? Let's try that again. Well, the point is, we have this, so we can actually calculate RT because it's just a horizontal line. From RT, that's just the distance of 4. 1, 2, 3, 4. So RT is equal to 4. But what about RS and ST? Yep, distance formula. We need to use the distance formula in order to get the proper distance. So RS is going to be equal to 0 minus 2 squared plus 2 minus 5 squared. So this is equal to 4 plus 9, which is equal to the square root of 13. We can leave it like that because now we want to compare with the other side, which is going to be ST. So ST is going to be equal to the square root of 2 minus 4 squared plus 5 minus 2 squared. So this is going to give us the square root of 4 plus 9, which is also the square root of 13. So we can actually see that these two sides are the same. The third side is different. So this is isosceles. We need to use the distance formula in order to classify this triangle. We can do the same procedure here for 14. So 14, if I graph these points first, so R is at 1, 1, 2, 3. There's R. S is at 4, 1, 2, 3, 4. 4, 5, 6, 7. And then T is at 5, 4. Fortunately, we have to use the distance formula for all of these. So let's start with ST. ST is going to be equal to 4 minus 5 squared plus 7 minus 4 squared, which is equal to 1, plus that's going to be 9. So this is ST is equal to the square root of 10. Then we have, so that's ST, then we have RS we can do. RS is equal to the square root of 1 minus 4 squared plus 3 minus 7 squared, which is equal to 9 plus 16. So that's actually the square root of 25, which is 5. So already two sides which are different, so it's not equilateral, but maybe it's going to be isosceles. So we do RT, which is going to be 1 minus 5 squared plus 3 minus 4 squared. So we get negative 4 squared, which is 16, plus 1. So we get that RT is equal to the square root of 17. Because all three sides are different measures, we can now see that this is scalene. Oh boy, that was a bad circle. What if I just, nope. Scalene. Making all sorts of mistakes today. All right, that's it for this, this lesson. Make sure that you remember the distance formula and really just how to classify these. Understand what it means to be equilateral, isosceles, and scalene, and then also acute, right, and obtuse.